All right, so they're playing games with us, rotations per minute. Let's get rid of that right away. 4,000 rotations per 1 minute. Let's get rid of minutes. 1 minute is 60 seconds. So it's basically 4,000, calculator turned off, 4,000 divided by 60, and I'm going to get 66.7 rotations per second, and that's my frequency. And what is the acceleration at the end of the test tube if it's 10 centimeters? Why did I say centimeters? So weird. 0.10 meters. Centi is 100. Move the decimal over. So we converted that. And we know A equals V squared over R. This is letter A I'm doing right now. The V, don't they want to know? Oh, no, they want to know the acceleration. I don't have a V, so I have to go kind of a step 2 and say V equals 2 pi R F. 2 pi, the radius is 10, not 10, 0.1. The test tube's going to stick out on one side and it's going to go spinning around, so that is the radius. Frequency we decided was 66.7 rotations per second. So to the calculator we go, 2 pi multiplied by 0.1 multiplied by 66.7, and I get a velocity of 40, let's just call that 42 meters per second. So back here we go 42 meters per second. Let's square it. Radius is 0.1. So my number's already in there. I squared it, divided by 0.1, and I get an acceleration of a really big number. My calculator says 17,563. That would be meters per second squared. We'd probably just call that 18,000 meters per second squared. If you're fancy, you'd say 1.8 times 10 to the 4th meters per second squared. All right. Our last one was 1.8 times 1.8. All right, let's do B. They want to kind of compare some acceleration to if we dropped it. So we're going to pull out a big old equation. V equals VI, or V squared equals VI squared plus 2A change in Y. My final velocity. Final velocity is what I'm interested in. My initial is 0. Square that, bye-bye, plus 2 at 9.8 meters per second, gravity. Change in Y, didn't they tell us it fell a meter? So I'm going to, so my VF is V squared, so I'm going to go 2 multiplied by 9.8 times 1, which is 19, so V squared equals 19.6 meters squared second squared, square root both sides, square root answer, and I get a final velocity of 4.4 meters per second. Now I'm going to throw that right back in there, not right back in there, into another equation where I'm going to go VF equals VI plus AT. I have to find the acceleration. My final velocity, we just decided, was 4.4. Initial is 0. And plus A, and it took 1 millisecond, which is 0.001 seconds, to hit the ground. And I need a little room here. I have to get A all by itself. I am going to have 4.4 meters per second. That's gone, and I'm going to divide by 0.001 seconds. Divided by 0.001, and I get an A, acceleration equaling 4427 meters per second squared, which is 4.4 times 10 to the third meters per second squared. And what was our last one? The fourth. So it is about 1/4 as big. So you take 4.4 times 10 to the third meters per second squared, and the other one was 1.4, wasn't it? Times 10 to the fourth, wasn't it? Dang it. Meters per second squared, and you throw that into your calculator. That's a 3 up there, believe it or not, divided by 1.8, EE4, and this is about 0.24 times, so 1/4. 1/4 is small. So the centrifuge is 4 times bigger acceleration. Woo woo, woo woo.